All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about the Inquire and what was the other one? Clap. The Inquire and Clap traits. I actually haven't made a whole lot of progress with the crates specifically since yesterday, but I have made progress in other Rust related things. And both yesterday and today, I was doing more research on how the into method works. I've finally understood how the into method works, and it's kind of interesting. I'm still doing a lot more reading, but the gist of it is, well, okay, the reading that I'm doing is on the concept of blanket implementations. So to demonstrate how the into method works, let's say I have this struct called myStruct01, and on this struct I have implemented the from trait um, for unsigned bytes, unsigned 8-bit integers, right? From is a generic trait, so like it takes in a generic type. So I'm implementing it for U8, which is an unsigned byte. And one of the methods that has to be implemented for from is, well, the from method. So you implement the method basically saying how from is going to behave when it is called. Now, the interesting thing is you don't call from uh, explicitly. I was trying to think of the word to use there. You don't call from directly. How it works is you have specified, or let's say, okay, we have specified a U8. We have implemented the from trait for U8 for our myStruct01. So anytime there's a situation where a myStruct01 is expected. So the context matters here. Anytime there's a situation where a myStruct01 is expected, we can create a U8 value and then use the dot syntax to call the into method. So basically, a very simple example here would be if we look at SO2. I've specified the actually let me do it from scratch so then you guys will be able to see it. Okay, let's say, okay, SO2. Here I explicitly type annotated saying that SO2 is supposed to be of type myStruct01. Okay, great. Now what I can do is I can type 10 and then dot and then into. So what happens here is the into method gets called. And if you look at the documentation for the into method, you'll see that it implicitly it calls u.from. U in this case, as we can see here, is myStruct01, and T is our U8. So yeah, that's how the into method works. What this is supposed to do, you can probably give different types of implementations for this, but in our case, what we are doing is the from method is supposed to take in a U8 value, and then it's supposed to return a myStruct01. So we can see here it says return self. So basically we are returning myStruct01 where one of the fields is of the U8 value that was passed in. This is just an example that I set up for demonstrating, actually learning, not even demonstrating. I'm demonstrating it now, but this is an example that I set up for learning how the into method works. Now, the next question that I had, okay, wait, to finish this off, when we call the into method here, 10.into, what we can see here is this returns, actually, so in the function signature, we can see it returns u, and u is of type myStruct01. And that is why we are able to call the into method. Now, there's another situation where you can, there's probably a bunch of different situations where you can use it. Another situation is something that I've demonstrated here. Um, Basically, it's a function that takes in an argument of type myStruct01, right? So in that situation, the function is expecting myStruct01. It's expecting, um, let's say, a value or an object of type myStruct01. Because of that, we are able to use our same, syntax as before. We're able to do a U8, so in this case it's 12, dot into, and then that returns a myStruct01. So the context matters here. The into method takes the, or well, whatever is enforcing, whether this method can be called or not, it takes the enclosing context into account. So there's an expectation of, um, if there's an expectation of a myStruct01, then we can call the into method specifically on U8 because we have specified, an implementation for that. Um, this does raise a question though. What if I did um, F32? Would that work? Because I haven't specified an implementation for that. There is an into method call though. What would this be calling? This should throw an error because there isn't an implementation for this. What happens now? Okay, it does throw an error. It does throw an error. It says the trade bound mystruct so and so so and so is not satisfied for the trade implementation. Expected U8 found F32. Required for F32 implementation is no required for. Oh, wait, are these two different lines? No, found F32 required for F32 to implement so and so so and so. Okay, all right. So this would only work if I created another block like this. Oh, what did I just do? Oh, yeah. This would only work if I created another block like this and pasted it there and changed everything to F32 instead of U8. So let's say F32, and then this will also be F32. And I think the rest is fine. Oh, okay. This, so to make this work, I'm gonna have to round off, is there an as int? No. What about round? That's still returning an F32. I forgot how you typecast, how you convert an F32 to an int. Is it U8 dot? No. Hold on. Let me ask Gemini. Um, because here the issue is that the struct is expecting a U8, so an unsigned byte. But for the sake of this, for the sake words, oh my God, for the sake of this example, I'm doing an F32 just to show that that works. Um, hey, how do I typecast uh, an F32 to an int, to a U8, let's say, U8 in Rust. I'm aware it'll round off. Um, Using the as keyword. Okay, dude, I don't use the as keyword nearly as much as I should. I just realized that. Okay, would this work? Value as F32. Oh, then I should be saying as you ate. Yeah, there you go. So now it works and we don't have an error anymore. Now, my next question here, which is something I'm still reading up on with Gemini, my next question was, how is it that I've implemented a from trait and, therefore a from method, but I'm calling an into method and apparently an into trait has been implemented. And it turns out this is the concept of blanket implementations. And I've come across this concept before. I believe it was in iterators. I believe it was in iterators. Hold on. I just realized that there might be massive lag. Shit, I forgot to refresh the feed. Yeah, oh my God, there's crazy lag. That's unfortunate. I jumped into the explanation and didn't look at the lag. Well, it is what it is. Um, what was I saying? Yeah, so it turns out this is a concept of blanket implementations where if um a certain condition is satisfied, then there's going to be a blanket implementation already done, so you don't have to, you know, do it yourself. In the case of a library, or even just in general, I don't know if Rust is setting up the implementation automatically or if if the devs have to set up that implementation. Like, is it like an auto implement kind of thing, or if it's one of those situations where um, the devs have also implemented an into, but because they have implemented an into, so you don't have to implement it. All you have to implement is the from, and the into method implicitly just calls from. So I'm currently reading up on that. I remember running into the concept of blanket implementations back when I was learning about iterators. Specifically, I think it was the into iter and iter traits. Yeah, or from iter. I don't remember exactly, but um, yeah, yeah. So I'm currently reading up on that, and I'm gonna finish reading up on that and hopefully learn about blanket implementations. So now, that being said, um, I guess we can just continue with learning about inquire and clap. So I'm gonna do a bunch of undos here. I hope NeoVim is holding on to the. Oh, there you go. Okay, great. So this is where we were at. I guess I can like rewrite the entire thing. I think pretty much I'm done. I don't really think I need to. I can write this from scratch. You know what? I'm gonna write this from scratch. I'm gonna write this from scratch. So here, wait, let's save it. There. Wait, give me a second. Okay. What was I saying? Oh yeah, yeah. So um we're gonna continue learning about inquire. I don't think I need to like go much further. I'm glad that in the example they showed how to do validations. And so I can, later apply that in other situations. And I'm glad that they also showed it in this way where we create, I mean, it's a closure, right? I kind of forget sometimes that you can just store closures into variables. It doesn't always occur to me. So when something is asking for a closure, when a function is asking for a closure, I'll just be like, you know, um, I'll type out the entire closure within the function call. Which, okay, hold on. So I've quick detour. We're gonna take a quick detour. Okay. How do I implement a closure? No, how do I implement a function that, okay, so let's say some func o1, um, and this takes, let's say f, um, what would it be? Like impl fn, I think. Would that work? And then we just call f. Is this okay? Okay, what if I do this? Precise format. Okay. Now, what if I wanted to pass in? What if I wanted to pass in arguments? How would that work? Is this okay? Would this work? No, that's not gonna work. This actually doesn't work either. Let me ask Gemini. Um, Also, wait, let me finish reading this thing about the as keyword. Okay, however, there is a slight catch with how the round off works. As performs a truncation, so it chops off the decimal part, not a mathematical rounding. You know what? That's great. Actually, that's no, that's actually great. That's better than rounding. That's better than rounding. Um, Not a mathematical rounding. Here's how to do it. Alongside, here's how to do it along with a safer alternative depending on what you need. The direct way is using as. This is the simplest method. It casts the float directly to the integer, saturating it if the value is out of bounds. Example, a float is greater than 255, it'll become 255. All right. Okay. I actually didn't take that into account. Yeah, I didn't take that into account. Note, as you can see, 42.99 as U8 becomes 42, not 43. Yeah, according to rounding rules, if it's more than zero point 0.5, then you would probably go, on the higher side, and if it's less than zero point 0.5, then you would go on the lower side. Okay. If you actually want to round it to the nearest whole number, before casting, you should use the round method first. My float dot round as so and so. Okay. Then the safer way is try into. Try into. All right. If you want to handle cases where the float might be negative, too large, or nan, so not a number, without risking silent data truncation, you can use try into. Sorry, zoned out. Okay, you can use try into because floats can hold values that a U8 cannot. This returns a result. Okay, and then we unwrap the result. Okay, okay. Right. Okay, all right. You know what? This is a good way if I am worried about like errors and if I want to make it completely concrete and error proof. If I want to future proof the thing, then this is good. For now though, I want to explore this thing. Hey, I'm learning Rust. I've created a function that should accept um, an FN closure. That's fine, but I'm not sure how to add arguments in there. Okay, all right. To pass arguments to a closure within a function, you just need to specify the types of those arguments inside. Oh, inside the parentheses of the fn trait bound. Okay, okay. Wait, trait bound. So I could I could make this. This is a trait bound, right? So I could make this a generic function. I forgot how you go about that. F T, and then I guess we do it down here where T is impl Fn. Does that work? Where does the is that okay? Is that okay? Why did dine come there? Dine dine doesn't wait. Dine doesn't belong there. Uh, hold on. Okay, I don't remember that syntax very well. Oh, there it is. Okay. So I got this part right, but then T is supposed to be Fn so and so. Oh, impl doesn't appear in that case. Okay. Also, to solve my problem, it's supposed to be this, and then how are we calling the function? Yeah, yeah. How are we calling the function? Supposed to be I32 and then so and so. Wait, that's odd. How is my like for example in validator with in the with validator function. Oh, in with validator, I believe the method is passing the value in um implicitly. So it's not the user that's passing in the value. I just realized that. I just realized that. Yeah, yeah. The user is not passing in the value. So if for example I write, hold on. Oh, why is all this still here? Let me delete this. Give me a second. Okay. And then in here we're gonna say let validator equals, oh wait, that's not what I was trying to do. Let's say text equals text new, um enter something, I spelled that wrong. Okay. Enter something dot. Let's put the dot here. With there's something wrong. Oh, all right. With validator, and here we pass in this. So when we call this function and we pass in the thing, what we already have, because this function is being called on a text object, right? So, okay, let's pass in an explicit thing because it's expecting an str, and then um, yeah, let's do print line validator called. Okay, and then we will do prompt. Wait, that's odd. Oh, um, this is supposed to return. This is supposed to return an OK validation dot valid. Yeah, then we go to the next thing and type prompt. Why is prompt not appearing? I'm missing something here. It is this. Give me a second. Yeah, it's still not appearing. I still am missing something. What am I missing? So we have with validator, we have our closure in there. Let's put the closure here. Oh, I forgot to close this. So that's what the problem was. And now we have prompt. So let it format the thing itself. Why was I doing this? I forgot why I was doing this. I completely forgot why I was doing this. Oh, so with validator is being called on this text object. What does this return? It returns self. What is self? Self has to be text, right? Or is text a trait? No, I don't think so. Um, V is yeah, okay. Impl so and so. It doesn't say for, so that means it's not a trait. So impl so and so, and then that's the function. Let me just confirm that that's how this works. Hold on, get rid of that error. Here let's do struct my struct o1. Uh, I need to, oh yeah, impl my struct fn some func o1. Why was I doing this? Hold on. Oh yeah, it was to see the, yeah. Okay. Okay, and right. Okay, I just added something in the arguments and in the return area because I wanted the placeholders to go away. I need to find a way to like skip over these placeholders. This is all part of a plugin that I'm using. Let's open up lazy real quick. Oh, what is that? Oh, changelog. Okay, what is the specific thing that I'm using? Is it conform? It's not conform. No, no. This was a different plugin that I enabled. It was something to do with snippets. It was mini dot snippets, I think. Yeah, I think it's mini dot snippets. I don't think there's anything else snippets related. There's mini dot snippets in oh, okay, no, friendly snippets is what mini snippets is using. Okay. So yeah, it's mini dot snippets. So I need to look into um what I need to look into like any possible shortcuts to, get rid of the placeholder things when I don't need them. Because right now, what I've got is I can hit tab, and that's a good thing. I'm not complaining. I can hit tab, and it'll constantly jump between the placeholders. And those placeholder characters will remain there until I put in something valid, and then they disappear. But what if I just didn't want to put anything in there? Then it becomes a bit of an awkward situation. Well, anyways, the reason I was doing this is to call this function. So let a equals my struct, and then we call a dot, that's not what I meant to do, a dot some func doesn't seem to be a part of this. What's the issue? Oh, it would be a part. Actually, you know what I could do? Yeah, if that's the case, I can just call it on my struct, right? It's an associated function unless I give it the self thing. So some func o1, this is what it looks like. See, I'm not seeing the same kind of information as I am here. Okay, let's try something else. Let's try uh you know what? Let's do it with a second function and add in. Wait, do they have code actions for this? Generate a documentation template, type alias, so and so. Okay, never mind. Um, let's say a equals, actually, just this. That should be fine, right? Okay. Now we'll call some func o2. Yeah, okay, it's still not doing that. Now let me check what text actually is. Text is not a trait. Yeah, text is not a trait. Right, so what I'm going to do then is copy this entire block. Let's do this and that. Yank. Okay, we're going to open up a new tab. Hey, I'm learning Rust. Um, I'm currently using the sorry, zoned out. I'm currently using the Inquire crate. In the crate, in text, I found the following function. Um, no, in text in with underscore validator, the hover info showed the following. Now, what I'm wondering is, keeping generics aside, let's say I have a simple empty struct. How would I get hover info similar to that? Because I tried implementing a function, no, implementing a method and an associated function. Neither, hold on, neither seems to generate similar looking hover info. Okay, what you're seeing in that hover info isn't actually two different functions or custom documentation formatting. It's the Rust analyzer breaking down two distinct pieces of architectural information about the exact same function. The definitive signature, the top half, shows how the function is actually defined in the source code, including its generic bounds. Then the inferred resolved types, the bottom half is below, is a dynamically generated helper. It tells you what type the generic parameter v was actually resolved to in your specific piece of code. To get hover info that looks like that, you don't need a special struct layout. You need a generic function that uses a trait bound, and you need, hold on, you need a generic function that uses a trait bound. Does it have to be generic? Okay, hold on just a second. Okay, so to be clear, what I was wondering is, why is it that when I implement functions on my own empty struct, I only see, let me copy that hover info. The following. Hold up. Specifically, what what I'm wondering is why I'm not seeing an impl um, statement there, the same way that I'm seeing it in uh, the with underscore validators hover info. That is a very specific nuance of how the Rust analyzer renders context, and it's a great observation. The reason you see impl so and so on the inquire crates hover, but you don't see it on your empty struct comes down to whether the impl block itself introduces generic parameters or lifetimes. Okay, okay, hold on. If that is the case, let's try. I forgot what the syntax was here. Does the generic need to be used? Impl type parameter is never used. Consider removing t, referring to it in a field, or using a marker such as so and so. If you intended t to be a const parameter, use const t instead. Okay. Uh, let's say a t. Are we good now? We are good now. Um, Now let's see. Okay, there it is. Now it's showing input. So that's the thing with generics and lifetimes. That was something silly to focus on, but that's what I was focusing on. Now going back to the other thing we were looking at. So what I've understood from this is that the with validator method is it has access to the text, and it is able to pass that text into the closure that we call. And I'm just now realizing that the closure that actually, wait, what if I don't ever provide a closure? So let's say I delete all of this, and let's say I've just started writing this. So it's not telling me what the closure what the closure is supposed to look like, right? Let's say I'm not going to pass anything in, and I'm going to call prompt here. I'm going to save. Um, Now it still doesn't tell me what the closure's signature is supposed to be. However, it is saying that the closure is supposed to return a string validator. No, the closure is of type string validator. Right. That's interesting. Um, that is interesting because if I decide to do how is a closure that I define over here? Let's say val equals str, okay, and then we just return okay, um validation valid. Is that good? That's good. Okay. Now i forgot I forgot what my question was. I forgot why I was doing that. Okay, let's get back to this. Oh, string validator. So how does the closure connect with string validator? Is that valid? Like if I because like if I pass in just validator, uh oh, it's called val. If I pass this in, does that work? Let's get rid of this. If I pass this in, does that work? Okay. Okay, that's interesting. So what this is doing is this is returning a result. This is an impl fn that's returning a result. The results type, interestingly enough, has not been specified. The results type has not been specified. But prior to this, it was a string validator. So I'm going to ask this question to Gemini. Okay, let's do that and that. Okay, yank. Right. Open up a new tab. Hey, I'm learning to use the Inquire Rust crate. In text, new dot with validator, um, the with validator method is expecting a closure of type string validator. I'm confused as to how the following closure qualifies. Let me copy my closure. Okay, it's completely natural to look at that method signature and wonder how a standard looking closure magically morphs into a specific string validator type. The short answer is blanket trait implementations. Okay, in Rust, string validator isn't a strict concrete type struct. No, isn't a strict uh, concrete struct or function pointer. It's a trait. All right, okay. String validator is a trait. If you look at the source code for the inquire crate, string validator is defined something like this. Okay, string validator, as long as it's returning. Oh, okay. So this comes back to the string validator thing that I'd opened up here yesterday. Where was it? No, not date select. It was under validation, string validator here. String validator, it has a validate method, and that is expecting. Hold on, I'm not sure what this is. I should look into this later on as well. More specifically, I'm not sure what this is. So I should look into this later on as well. But fn validate, okay, okay. If the input provided by the user is valid, your validator should return so and so. If the input is not valid, your validator should return so and so and so and so. So it's always going to return a validation. It's always going to return some sort of validation, whether the validation is valid or invalid. It's going to return a validation. Custom user error, I guess I can explore that later on, like why, in what situations we would have that. Or maybe it's just like, maybe the error gets propagated from error message to custom user error. Actually, no, that wouldn't be the case, right? Because if validation is being returned, then there's not going to be an error in the result. Yeah. Okay, let's continue reading. Because with validator accepts any type v, where v is a string validator, any type that implements the trait is welcome. Any type that implements the trait is welcome. How does my closure implement that trait? Yeah, how does my closure's type, so the type that we are then passing in here is specifically, actually it's shown here, right? Now it's not mentioning the thing here. However, the types here are validation, and the other one is probably custom user error or error message. I don't remember. Um, okay, the blanket implementation. The magic happens because Inquire provides a blanket implementation of of the string validator trait for any function or closure that matches the. Oh, okay. It provides this blanket implementation for any of the string validator trait for any function or closure that matches the expected signature. That's interesting, dude. So this is what Gemini is showing. Actually, hold on. The blanket implementation might be mentioned in this list as well. They do they do mention blanket implementations. Traits string validator. Hold on. Did that go to a new page, or are we still on the same? We're still on the same page. Okay. Um, trait implementation clone implementers. Do they? I don't remember if they call it blanket implementation, but okay, this might be it. I think this might be it. Impl so and so. I think this might be it. I'm not sure though. I'll have to look into this. Maybe I'll just copy paste this page to Gemini and be like, okay, show me where exactly it's mentioning that there's a blanket implementation, because I do remember seeing blanket implementation mentioned in, I forgot which one it was, from iter or just iter, or maybe there's a to iter as well. Man, I don't know why I'm yawning so much. Okay, anyways. So according to Gemini, apparently there's a string validator trait, or there's an implementation of the string validator trait for any function or closure that matches the expected signature. And in our case, the expected signature is uh, basically basically an fn that, in our case, okay, the expected signature is um, fn str um, returning result validation and error message. I don't remember if the last one is I don't remember exactly what the thing was, so I can't say for sure if that's accurate, but yeah, this is the signature, including the return type. This is the signature. So I'm guessing there's a blanket implementation for any closure that has this kind of a signature, which is interesting, dude. I need to look into how you would go about setting up something like that. Yeah, that's really interesting. Um, Apparently the blanket implementation looks like this. I'm just going to copy paste the thing into this buffer. This is what it looks like. It says impose string var, and that's actually down here. Yeah, the method itself hasn't been defined. However, we have this. Yeah, so result validation custom user error plus clone. So it says here impl so and so for f. So for any type, f f here is the type, but it's meant to be a closure. So we implement this trait for any type. So that essentially then satisfies the trait bound, right? Because we have a blanket implementation. So that then satisfies the trait bound if, needing a string validator. And how are we going from yeah, see, I'm confused about that part. How are we going from with validator to with validate or sorry, how are we going from with validator to validate? I'm having trouble making that connection because we are calling with validator, right? That is, let me save this, come here. We are calling with validator. Okay. Now, within this, all this is doing is returning a result. At what point does validate get called? Wait, let me continue reading what Gemini said. This tells the compiler if there's a closure or function that takes a string slice and returns a result with validation and custom user error, automatically give it the string validator trait. Okay, dude, that's actually crazy. Hold on, that's actually crazy. So we can this is okay, so this is an example of a blanket implementation, isn't it? This would be an example of a blanket implementation. So I could maybe reproduce this behavior by saying, wait, let's delete this. I could, it's a trait, isn't it? I forgot how you do traits. Let's say some trait O1, and then in here, I don't know, fn some t func O1. And this doesn't have to take anything. Yeah, see, I don't know how I can get rid of these these two placeholders in case I don't want to do anything with them. Oh, just filling it out. All right. Um, Hold on. I wonder if Oh God, don't do that. You know what? Okay, I'll test that out later on. Right. What I'm looking, I do not need this actually. I just realized that. Yeah, what I need is this trait, func, missing. Oh, parentheses. All right. Now this has to be a generic trait. How do I use generic parameters here? Does that work? What does this say? Expected a name. Where? Hold on. Place the generic parameter name after the trait name. Oh, okay. Okay. I'm glad that it I'm glad that it added that info. Uh, are we good now? Now we're good. Okay. Right. So, um, now how? Yeah. Okay. Okay. I can. How do I go about this? It's for functions as well, right? Functions and closures. So then, would we say that the function satisfies that? I don't know about that one. No, no, no. Hold on. Let's stick to closures for now, because the example that I was going to use to try and like demonstrate that, I don't think that works. Um, but yeah, okay. Impl. Do I need this? Some trait for F. Oh, the yeah, I have to specify the where. Where F. Let's give it a closure. What if I want it to be a function? Can I do that? So far, it's about wait. So we can pass in for a function or a trait. For function, I guess we can just pass fn, right? Fn would work because my mind keeps connecting fn to closures. Uh, okay, let's just have a simple function that returns an I32, and we will just create an implementation saying um, I don't know, some trait or one uh, trait bound satisfied. Okay, are we good? We are not good. Rust cannot find the type F. Do I have to put F here as well? No. What does the thing look like over here? Missing generics for trait some trait O1. Add missing generic argument T. Oh, maybe I don't need this. Yeah, okay. The whole idea was just implementing the trait. I was just confused about where I'm supposed to be using generics. So here we are creating, I'm assuming this is an example of a blanket implementation for a function that returns an integer. So what we're going to do is we're going to create a function called somefunc um, o1 that how is some t func o1 being called? How does that work? because we have the function, right? Can we actually call, like, okay, wait, some func01 is so and so, it returns an I32, and we pass, I don't know, 0. Oh, 0. That's done. Okay. If I, that doesn't work. However, wait, yeah, no. Um, if I call some func01, but that's returning, yeah, that is not gonna work. That's not a good example. Um, what if I created, okay, let's say f01 equals this, um, and it returns 3. That's okay. Yeah. So now, nope, I still don't have it. Oh, maybe this requires self. Is that gonna work? I don't think that's gonna work here. I'm trying to reproduce this, but I'm not able to. Self input. Self should work, right? What's the error that it's giving? Has self has a self declaration in impl but not in the trait. Then let's add it to the trait. Wait, am I able to? No. Okay, never mind. Self. Okay, now there it is. All right. Okay. Okay. Now I get it. So what I'm guessing is happening is because Gemini mentioned that this has been implemented, the validate function has been implemented. I'm guessing what's happening is that when we pass in our our closure, it's calling validate on the closure. But then how is the data going from the closure to the validate function? I should explore this more. However, unfortunately, I do need to end the stream at this point because yeah, I ended up starting the stream late again today. It is what it is. I'm gonna try and I'm gonna words. I'm gonna try and start the stream earlier tomorrow. Um, hopefully I'm able to. But yeah, dude, we made some good progress. We didn't make progress with, I mean, kind of, because we were basically exploring, Inquire related stuff, but it was more me learning about blanket implementations, and I'm really interested in this right now. So I wanna continue with this. But yeah, dude, that's gonna be it for today's stream. I don't think I'm rating anyone today. I'm just gonna end the stream. Um, yeah, yeah. So that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.